Recording in progress.
Yeah, good morning. Sorry, good evening. Good evening, everyone. Online students, everyone can hear me? Is my voice is loud and clear? Done. So let's start this session. In the last class, we have discussed in terms of introduction to NLP, right? So let's have a small recap, whatever we have done in the last class. First, we have done initially the introduction to text mining. What is meant by text mining? Right, where you are going to work on the text data. If any text data, if you are extracting the data and you are working on the text and you are mining, in that mining means you are exploring and analyzing, is called as mining. Mining means exploring plus analyzing the data, right? So introduction to text mining, what is meant by text mining. Next, we have seen to what is meant by NLP. NLP means natural language processing, where it is able to process the natural language, means whatever we are speaking, irrespective of grammatical mistakes, still it is able to process the data. So that is called as natural language processing, right? Now, next we have seen with respect to in the natural language processing, what are the different types we can work. That is with respect to one of them is called as sentimental analysis project. And like this, we have seen with respect to different applications like document clustering and chartboard. These are the multiple applications of like this. So many applications are there, multiple applications. Now, next we have seen in NLP, if you want to work for any project, first we have to start with the tokenization. Tokenization means breaking into the parts, either sentences or words. Word, if you are breaking into sentence, means sentence tokenization. Words means word tokenization. Then followed by we have understand text cleaning part. The text cleaning part involves in terms of removing the punctuation marks, because there is no importance of removing with the punctuations. But when it is having no importance means when you are working on the sentiment analysis, or when you are working on the documentations, or with respect to when you are working with respect to some kind of projects where exclamatory mark, punctuations, and with respect to whatever the grammar is there, If you are involving a project with grammar, in that case, everything is important. In the case which is not having any importance of grammar, in that case, this is not important. So remove the punctuations. We are going to remove the stop words. Stop words means unnecessary words, which are not useful for making the sentence. It will not give any information. Just it is used to form the sentences. It will not give any information. And next one is called as stemming or lemmatization. In which case we are going to use the stemming, in which case we are using the lemmatization. These are the things which we have discussed. And once this is completed, vectorization. We are doing the vectorization. In the vectorization, we are converting the data. Whatever the data we are having, we are converting that one to the numerical vectors in terms of a numerical vectors. So in order to convert a text data into a structured data, we are going to use the vectorization. Within the vectorization, we have seen what is meant by bag of words, BOW. That is nothing but count vectorizer. These are the things which we have completed in the last class. Now in today's class, we are going to see the next one called as Naive theorem. Okay, next type of classification algorithm. Okay, this is also basically a type of algorithm. Okay, Naive. Okay, Naive. This is also one of the classification algorithm. Okay, sir, you are saying this is a classification algorithm, means it is a supervised machine learning. Then why didn't you explain during the normal classification algorithms like SVM or with respect to decision tree or KNN? We have discussed that one also, right? Why you have not explained at that time? Why you are explaining now? Because this importance now you can understand very clearly. When we have to use the Naive theorem, so by understanding this algorithm and along with the application of Naive, so that you will get a more clarity on that. So for example, Naive is a classification technique, works on the Bayes theorem. Okay, there is basically a Bayes theorem. For Bayes theorem, we are adding the Naive. Now, what is meant by Naive and what is meant by Bayes theorem? Both of them will understand clearly. Let us assume that you are a data scientist working at a major bank in the New York City and want to classify the client is eligible to retire or not to retire. So the same example which we have considered in the decision tree during that, right? So we are having two columns. One is age and what is the salary. Two options we are having. Okay, this is the case. Now we know for any new data, if you want to identify whether the person, any new data, some new data point is there, this data point, whether it has to be retired or not to be retired, means in the KNN, we are identifying the nearest neighbors. In the SVM, first we are going to take with respect to separate the data points by increasing the higher dimension. And in the decision trees, we are going to make with respect to the rules, some kind of rules, and where we can classify the entire data. So by using the linear, by using the conditions, first by writing like this one condition, like this one condition, and you are going to separate. Finally, you are going to separate each and every data point. So each algorithm works in a different way. Now let us see how Naive will work if this is the data. Now we are having two categories. One category is called as the person has to retire. Okay, class 1. We are having class 1. 40 data points are there. Not to retire, 20 data points are there. Miss total how many records are there? 60. The data set is of 60 records. 60 records is the data set. Out of which, if you consider the output variable, dot value counts. If you apply for the output variable dot value counts, you are getting in terms of two classes. The class 1 with respect to 40, class 0 with respect to 20, right? This is the meaning. So I'm having a data set of 60 records where 40 records says that the person has to retire. Records are like that. 20 records are with respect not to retire. Now there is a new customer. Whether this new person has to retire or not to retire based on the age and based on the savings. Now how we are going to work this one means, first we are going to calculate the prior probability. Prior probability means before to this, the original data, what it consists of. What is the probability of being read? What is the probability of not to retire? Can anyone tell what is the probability of not retire, no retire? What is the probability? 20 by 60. 20 data points are there out of 60. Total 60. We have already know what is meant by probability. Now, what is the probability of retire? 40 by 60. Whether you give a new data point, if you don't give data point also, the answer is same. This is prior. Prior means whatever the original data set was given, that is the answer. This is called as prior probability, means original, whatever we are having before to this. Before estimating on a new person, what is the old one we are having with us? That is called as prior probability. Now, prior probability of class with respect to red is 20 by 60. Prior probability for blue is 40 by 60. Is that clear? Prior probability word. Prior probability word means before estimating, before to that whatever we are having. Right? Now, here, second one is called as likelihood. Next second word is there called as likelihood. Now, what is this likelihood? Means in that given, for example, I'm considering a given area, one area. Okay. So here I'm going to take one area. Don't later we'll discuss how to select this area, that we'll see later. Now assume this is the area. In this area, how many data points of red are there? Means 3 out of 20 red points are in the close. One data point out of 40 is very close to this one. Okay, one blue point out of 40. 3 red points. This is 1 by 20. This is 1 by 20. This is 1 by 20. If you add everything, means it is nothing but 3 by 20. Basically, each red point is 1 by 20. Total 20 red points are there. Each point is 1 by 20. So 3 are there. 3 by 20 and 1 by 40 is the likelihood, being as a likelihood in that area. Right? Now, posterior probability. Now we are having the posterior probability. Posterior probability is equal to, the posterior probability is equal to prior probability into likelihood. Prior probability is 20 by 60. Likelihood is 3 by 20. Now, what is the answer you are going to get is 1 by 20. Similarly, posterior probability of being blue is, prior probability is 4 by 60 and likelihood is 1 by 40, which is 1 by 60. This is called as posterior probability, which is nothing but Bayes theorem. Calculating the post probability is called as Bayes theorem. Okay. Now, what is meant by Bayes theorem is Bayes. Basically, Bayes. Bayes theorem is nothing but if you want to calculate a particular probability, you have to take the prior probability into likelihood. Prior probability into likelihood is called as probability of any particular data point. Probability of A. Okay. So here, if you're considering the probability of B, see here, clearly observe this one. Posterior of probability of X being as red. This 4 is there. Without being as red, normal X is different. Posterior probability, just observe this point. So here, the posterior probability, whatever the posterior probability is there, the posterior probability is equal to prior probability into likelihood. Posterior probability is equal to prior probability into likelihood. This is called as Bayes theorem. Means the probability of A by B is equal to, the probability of A by B is equal to probability of A and what is the probability of being as a likelihood of this one. So here, if you observe this one, this is a probability of A by B. A by B means the probability of A being as a red, means whatever the given data point being as a red, that is in this case, in this example, the post P of X, any data point being as a red data point is equal to prior probability of red into likelihood. Likelihood means in terms of given data that is red with respect to X. How many red points are there? How many red points are there into how many blue points are there? So the prior probability, the posterior probability is equal to the prior probability into likelihood. This is the formula. Okay. Similarly, the point being as a blue data point is equal to the probability of only blue. Separately calculate the probability of blue into in your area, how many blue points are there close to the X. Right? So this is called as posterior probability. Is that clear, guys? So prior probability, likelihood, and posterior probability. Now the same logic we are going to apply now, and let us see this one. So here Naive-Bayes theorem is, so a person being as a retire, whether the person has to retire, that is nothing but red or with respect to blue is equal to Naive-Bayes theorem is nothing but your likelihood into prior probability divided by the original probability. Okay, so this is also called as conditional probability. This is called as conditional probability. So likelihood into prior probability divided by marginal likelihood is called as conditional probability. Now, let me explain what is meant by conditional probability. Later we'll see the formula. Later I will explain once again the formula. Don't worry. Conditional probability. Now, what is meant by conditional probability means what is the probability of A when B is occurred? What probability of A by B, meaning of this one is what is the probability of A when B occurred is called as conditional probability. Sir, what is the meaning of this? For example, what is the, for example, let us take India, Australia. There is a cricket match between India, Australia. Okay. There, what is the calculating the probability of India winning? What is the probability of India lost? Okay. It is going to lost the match. We are having two options. Now calculating of India winning and calculating of India whether to lose losing the match. Okay, means whether it is going to lose the match. How we are going to calculate the probability? We are going to say earlier how many matches they have played. India, Australia, how many matches has been played? For example, India versus Australia, they have played, assume 100 matches they have played. Out of India has won 51 matches, out of which Australia has won 49 matches. What is the probability of India win miss? 51 by 100. What is the probability of Australia miss? 49 by 100. That everyone knows. This is a simple calculation of probability. Now here the question is not that one. The question is what is the probability of India win when India won the toss? And what is the probability that India will lose the match when India won the toss? Now here, if you want to calculate this probability, what you have to do compulsory is first India has to win the match. I mean toss. So indirectly what you are calculating, what is the probability of India winning when India has won the toss, when it has won the toss. You are not calculating when India lose the match. I mean, sorry, toss, when it has lost the toss. For example, opposite, toss is opposite and it has lost the toss. So you're not calculating the probability. You are calculating only the probability of India winning when India has won the toss. Now, now India versus Australia match, whatever we are having, now total 100 are there, 100 matches are there. Earlier I have told you India has won 51. Australia has won 49. Okay, this is okay. Out of these 51, within that, how many matches the toss was won? Assume it is 29. How many times it has lost the toss? Lost the toss. How many matches balance? How many are there? 22. 22 it has lost. 29 it has won. So now you are calculating what is the probability when it has won. Okay. Next, This is one of the example. Now let us see one more example. Let us see one more example. So here I'm having with one more example, like what is the probability that girls will do the shopping? They are going to do the shopping. General shopping means it is general, normal shopping. When they are going to do the shopping, though it is raining, what is the probability that the girls are going to do the shopping, though it is raining? Means here, first raining has to be occurred. Now there will be some situations where rain will be there. There will be some situations when rain is also not there. So here, what you are going to calculate? What is the probability that girls are going to do the shopping when rain? It is raining. When it is raining. When it is normal days. When it is normal days, you are not going to calculate. You are not calculating for the normal days. Only when it is raining, what is the probability? Okay. So what is the probability of boys shopping when it is raining? Common is shopping is common, whether boys or whether it is girls, shopping is common. But here, when it is raining, what is the probability? So when it is raining, the boys generally they'll not go to the shopping. They'll simply say it is anyways raining now. Let us go and do some other work. Something they'll say. But girls, once they have fixed shopping list, they'll go to the shopping, though it is raining also. Okay. Example. Okay. The same data set is also available. Proof also available. Okay. For everything, proofs are there. Don't worry. Right. So just in terms of for the given data set, you are separating the data with raining data without non-raining data. So entire data first you are separating based on the rain. Separated. Within the rain, again you are calculating what is the probability. Separately you are going to calculate. For what is the boys shopping and what is the probability of girls shopping during the raining. Right? So like this we are having with respect to different scenarios. So in this commons, what is the meaning of this? All the things means conditional probability. Conditional probability means when B condition occurred, when this condition, B condition occurred, what is the probability of A? We are calculating what is the probability of A when B occurred. B should be occurred. If B is not occurring means no need to calculate the probability. So now just observe this one. Okay, clearly observe this one. Whatever the posterior probability we have calculated here, what is the posterior probability of X being as a red? Means you are calculating the X with respect to red. What is the probability of X being as a red? Now, first you are calculating how many red points are there, and within that red points, how many are very close to me? Basically, how many are there? And within that, how many are very close to this particular data point? So that is prior probability into likelihood. Now here we are having this one, which is called as Naive Bayes. Naive Bayes means divide by overall probability. So now here, let us take like this. So for this same example, I'm having the overall, the P of retire is 40/60. And within that, in the given data, only one blue point is there, that is 1/40. And total, how many I have taken? In my circle, how many I have taken? 4 I have taken. That is divided by 4/60. For example, you have taken a circle like this. Assume. In this circle, how many blue points are there? How many red points are there? Overall, how many data points you have considered? Whether it is 4, whether it is 5, whether it is 6 or anything is okay. But for example, now here I have considered only 4 points. I have taken only 4. 4 out of 60 I have considered. Within the 4 out of 60, this is the probability. And being as a blue point, what is the probability of being as a blue point? Means 0.25. Now tell me, what is the probability of being as a red data point? What is the probability of being as a red data point that is not retire with respect to X? What is the probability? With respect to first prior probability. What is the prior probability? Prior probability is 20/60 is the prior probability. into likelihood. What is the likelihood? Likelihood is 3 by 20. 3 by 20 is the likelihood. Divide by total how many points you have considered? 4 points. 4 out of 60. Got the point? Once again. P of with respect to not retire or which is bracket red data point. P of red being as a red for a given data point being as a red is equal to prior probability. What is the prior probability value? 20 by 60. 20 data points overall 60 into likelihood. What is the likelihood? Likelihood is with respect to 3 by 20. 3 are now 3 within 3 you have taken 3. Okay, from 3 from how many? Out of total how many? Out of total how many? Out of 4, 3 are likely. Overall you have considered 4. This is the maximum likelihood. This is with respect to maximum likelihood. That is with respect to 4 by 60 you have considered 4 out of 60 data points you have considered. Within that 4 out of 60, red only 3 are there. Right? That is the meaning of that. Now similarly, what is the probability of retire? Retire means blue being as a blue data point. Again, prior probability. What is the prior probability of blue? What is the prior probability of blue? 40 by 60 is the prior probability. And likelihood in your circle, how many are there? 1 out of 40. Total, how many data points you have considered overall? 4 only. Means in this case, the denominator is same only. Denominator is same. You no need to focus on the denominator. You have to just focus only on the numerator. So now here, what is the value means? You are just calculating 20 by 60 into 3 by 20 divided by 4 by 60. And what is the probability of this one? You are going to calculate separately. Once you calculated separately of this one, that is 40 by 60 into 1 by 40 divided by 4 by 60, which is 0.25. And for this one, it is 0.75. Overall, it is total should be 1. Overall should be 1 because only 2 classes are there. If this class and that class. Okay, total 0.75. Now 0.75 means with respect to, since more, what is the more probability? With respect to being as a not return, means being as a red only, more probability is there. So you are going to classify this data point as a red data point. Now the question is like this. Sir, for this data point, now let us consider this many points, sir. Okay. For this data point, I am considering these many. How it is decided, that I will show you. Assume these many data points are taken. Okay, these are not considered. Only these many points are taken. Now, if this is the case, now in this case, total how many points you are considering? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total 15 points you are considering. Out of 15 points, how many red are there? 6. How many blue are there? 3, 6, 9. So total you are considering 15 points, out of which 6 are red, 9 are blue. Okay, this is the case. Now, what is the probability of the given data point being as a red data point? What is the prior probability? Prior probability of red, 20 by 60. This is the prior probability. What is the likelihood? Likelihood is with respect to 6 by 20. Divide by total how many data points you have considered? 15. 15 by 60. Similarly, what is the probability of being as a blue, which is prior probability? Prior probability is 40 by 60. And likelihood means 9 by 40 divided by 15 by 60. Okay. So now just calculate this one. That is 1 by 3, 3 2 times, that is 2 by 20 into 60 by 15. This is nothing but 23, sir. That is 6 by 15. 6 by 15 means 0.4. Is that okay? Now, this one is 2 by 3, 3 times. That is 6 by 40 into 60 by 15. So that is nothing but 0 cancels. 36 by 60, which is nothing but 6 by 10, which is 0.6. Okay, final calculation is in whatever the way you do the calculation as per your choice. Finally, the answer is 0.6. Now, if this is the case, now which is having the higher probability? Blue is having the higher probability. So it is going to convert as a blue data point. Now the question gets, sir, how many data points I have to consider? The circle, how I have to draw? That is the question. Now you are not going to draw any kind of circle. If that is the case, I have told you the example. You are not going to draw any kind of circle. Now, without drawing the circle, then how we are going to work? Let us see that one. Okay. So that I'm going to explain. Before explaining that one, let us work on this data set. Okay, let us take one data set where in this data set, I want to do the classification of whether it is a spam mail or whether it is a normal mail. Normal means ham mail. Ham means normal. Okay, whether it is a spam mail or a normal mail means I'm going to get one mail and this mail should be classified either as a spam or ham. Two options I'm having. Either spam or ham. Now, this is the project. Now, for that, what I'm having is original data set they have given to me. Okay, one original data set was given. In that original data set, so just don't focus on anything. What I am explaining, just observe. In this, so much of things are there. So in the given data set, original data consists of 100 maize. Out of 100 maize, 72 maize are with respect to normal maize. I'm having with respect to 72 of them are normal maize. That is ham. And 28 maize are with respect to spam. Okay, in the original data, in the output variable will be available, right? In the output variable, I'm having 22 of them, 72 of them are ham, 28 of them are spam. Now tell me, what is the prior probability of ham? Prior probability of ham. What is the prior probability? Prior probability of ham. Probability of ham is nothing but 72 by 100, which is 0.70. This is prior probability. Now, for similarly, prior probability of, what is the prior probability of spam? Which is nothing but 28 by 100, which is 0.28. This is the prior probabilities. Up to here, it is clear. Now, within this 72 maize, multiple words will be there, right? Some of the words might be repeated, some of the words may not be repeated. Bag of words. What is meant by bag of words? Just it is going to count. For example, in that one of the mail, first mail, assume that first mail is having good boy. The first mail is having like this, assume. First mail is having like this good boy. Now, what it is going to do? Wherever the word called as good is there, good boy, girl, assume. Yesterday's example. If this good boy is there, Now in the count vectorizer, boy is repeated 1 time, girl is taken as 2, good was taken as 2 times. How many times are there? It is going to write that one number. It is not always with respect to 1 or 0. It is going to count. It will give the count. Count vectorizer means it will give the count. How many words are there? With how many words are repeated. So this going to count the count vectorizer will count the number of words. Now let us assume there is a situation where I'm having overall 100 males are there. Out of ham males, a normal males are 72, spam males are 28. And what is the probability of being as a ham is 7.72. Probability of being spam is 0.28. This is up to here. It is prior probability. Keep this one side. Now within the ham is total 717 words are there. Overall 717 words are there. Out of which 717 count is overall. Friend word is 86. 86 times the friend word was repeated. Rich word was repeated 41 times. Money word was repeated 79 times. Beach word was repeated 80 times. Office word was repeated 75 times. Okay. Now, what is the probability of being friend in ham? In ham. Then what is the probability? What is the probability in ham? Friend in ham. What is the probability? That is 86 divided by total, which is nothing but first you do the total of this one. The total of this one is nothing but what is the total with respect to 717. Just you are going to calculate the probability. Similarly for rich probability, for money probability, for beach probability, for office probability. Like this you are going to calculate the probability. This word within the ham, this word within the ham, this word within the ham. So you are going to separate the ham data, and within the ham data, you are identifying the separately. Got the point? Is that clear? This point is clear or not? Anyone has any questions? Up to here. Now, there is with respect to a new male. I'm having a new male. A new male is having friend, a rich, beach, money. After doing the data cleaning and everything, finally, I have got these are the 4 words in the male. Now, whether this male belongs to a ham male or a spam male. Now, I have to calculate this one. A new male. Whatever the new male is there. This new male being as a ham. What is the probability of being as a ham? And a new male. Whatever the male I have got being as a spam. I have to calculate separately both the probabilities, and whichever the probability is high, I'm going to select it into that. Is that clear? Now for this, what I'm going to do first, probability of you are having like this means first what you have to do, probability of with respect to prior probability. Prior probability means what is the prior probability of ham? What is the prior probability of ham? 0.72 into. In this new male, what are the words are there? There will be unique words now. Each word, first word. For example, what are the words are there in the new male? Friend, rich, beach, money. Okay, I'm writing that same thing. Friend, rich, beach, and what is the 4th one? Money. Okay, total 4 you are having. 4 of them. You are having total 4. Now I'm going to calculate what is the probability of friend being as a ham. What is the probability of rich being as a ham? What is the probability of beach being in ham? And what is the probability of money in the ham? Separately for each word, I will calculate the probabilities. Once for each word the probability is calculated, I'm going to calculate the overall probability. Divided. And similarly, same way, a new male, whatever the new male is there, this new male being as a spam. Now, what is the prior probability of spam? What is the prior probability of spam? That is 28 by 100 is the prior probability, which is nothing but 0.28 into likelihood. Likelihood means for each value. That is, again, friend being as a spam. In the spam means friend word will be different. Friend word in the ham will be different. So the rich with respect to spam, and beach with respect to spam, and with respect to money with respect to spam. So I'm going to calculate in this way for each of them. Whatever the separated words are there, for each word, I'm going to calculate what is the probability with ham and what is the probability with spam. Sir, you are taking the numerator. In Naive-Bayes theorem, numerator is okay, sir. Where about the denominator? Anyways, denominator is same only na. For that one and for this one, denominator is going to be same. So since denominator is same, just you can ignore the denominator. Ignore the denominator. Now, if you are ignoring the denominator, what is the meaning of ignoring the denominator? What is the meaning of ignoring the denominator? So here, what is the meaning of ignoring the denominator means nothing but, though you are considering 4 also 4 by 60, you are considering 40 also divided by 40 by 60 only. So that one only you are not considering. So if you are considering 10 also not a problem, 4 also not a problem, 20 also not a problem. Because denominator is not important for me, because denominator of both of them is going to be the same. In that case, in this case. For example, sir, here in this example, if you ignore the denominator, sir, remove the denominator, then what is the probability of this one? 1 by 60 is the answer. Then calculate what is the probability of this one? 3 by 60. Out of these two, 3 by 60 and 1 by 60, out of these two, which one is high? 3 by 60 only na. Now also answer is same only na. Before that also the answer is same. You are having with respect to 1 by 60 divided by 4 by 60 is 1, and 3 by 60 with 4 by 60 as 1. If you ignore the denominator, now you are considering only 1 by 60 as one class, 3 by 60 as one class, and finally you decided this is the answer. If you keep this one also, answer is same only. There will be no difference. If you keep that one also, answer is same. If you don't keep also, answer is same. So since there is no difference in the denominators, so simply you can ignore the denominator. Just then what you have to do is, so simply you have to take the Bayes theorem. That is, Bayes theorem is probability of A by B is equal to probability of probability of B, prior probability, that is B, into probability of B by A. Is that clear? Simple. So the same thing I'm applying here, the logic. Just observe this one. So here I'm having the spam separately. I have taken spam. I have taken separately. Now there is a word. For that word, whatever the new mail is there, in that new mail, for each word I'm calculating the probability separately. And out of these two, which probability is highest, I'm going to select that one as the answer. Since the probability of ham is highest, the answer is ham. If the probability of spam is highest, then I'm going to consider as the spam. Which word is highest? That one. Sir, how you got this one? First tell me from where you got this one. Okay, from where you got this one means in the original data is there now. Original data, separate the spam, separate the ham. Got the point? Is that clear? Clear, guys? Now let us see the coding part. For the same, let us see the coding part. Now here I'm going to import the pandas as PD, and I'm going to take the data called as spam collection, and this data is a flat file. If you observe the data set, so here till now we have worked on the CSV or Excel. Now one more file, we are going to work on the flat file. It is neither CSV, neither Excel. Okay, now this file, whatever the file is there, if you open the file, okay, if you click on the open with, and I'm going to open with Notepad, using the Notepad. Now here, if you observe this data, this is the data where I'm having with respect to the data was separated by considering the tab space. Between them, tab space is there. The data was separated based on the tab space. Okay. And since the data was separated using the tab, so here what I'm going to do is I'm going to load the data by writing the separator is equal to tab. Separator tab. Before to tab is 1, after the tab is 1. So this I'm going to consider. Okay. So now if I consider the first one automatically, if you observe here, the first one in this, whatever the heading, the first one is considered as the heading. The first one should not be considered as heading means, then what I have to do means I have to add the columns. So columns I have to add means the columns I have given as the names. Sir, you can write the word called as columns now. Columns word can be used when you are writing pd.dataframe. When you are writing the pd.dataframe function, in that columns will be created by that one. When you are using the read underscore CSV, the columns should be given as the keyword called as names. In this function, the columns are considered as the names. So now I have given the name as this one as the output variable and this one as the my mail. Got the point? How to load the data? This is a flat file and the flat file I have loaded. Once I have loaded the data, now I'm going to click on the info. Total 5,572 messages are there, mails are there. What are the messages? Now here the label, whatever the label is there, in the label I'm having either spam or ham. Now I'm going to calculate the value counts. I'm going to calculate value counts. Value underscore counts. So total you are having ham mails of 4,825, spam mails of 747. Now you want to calculate the prior probability. How to calculate the prior probability, guys? How to calculate the prior probability? Prior probability is nothing but the original divided by the whatever you are having overall, divide by overall. Simply divide by length of DF. Now you will get the percentages. What are the percentages there? That is prior probability only. Okay, percentage is nothing but prior probability. Either you can divide by length function or inside simply you can write normalize is equal to true as per your choice. If you can remember normalize is equal to true means that is the best option. If you can't remember means this one, because in the backend automatically it will apply this one only. Whether if you write like this also the same thing, normalize is equal to true. If you write this one also there will be no difference. Answer is same. These are the prior probabilities. Keep the prior probability aside because prior probability is a very, very simple topic. Keep this one aside. Now what I'm going to do is first I'm going to do the cleaning. Cleaning means remove the punctuations, remove the stop words, and whatever the output I have got, either I have to apply stemming or lemmatization. For this particular project, since it is not going to ask, we are not having any kind of interaction. There is no human interaction here. Just whatever the data it is doing manually. It is not speaking with me. It is not going to share one output for me. So directly I'm going to apply the stemming concept. Now stemming means now it is going to take one after one after one after one. Like that, how many it is going to take? Total 5,572 messages. First message it will take and it will do the cleaning. Second message cleaning. Third message cleaning. Fourth message cleaning. Like that, it is going to take total 5,572 messages. It is going to do the cleaning one by one. Now, once the cleaning is completed, the entire cleaning is completed. Now, in that, what I'm going to do? Count vectorizer. I'm going to apply the count vectorizer. How to apply the count vectorizer means from sklearn.futureextraction.text import count vectorizer. Okay. Now, sir, before showing you count vectorizer here, let me show you with a simple example what we have done in the last class. That is, in the last class, do you remember, guys? We have worked with a small data set. That is with respect to he is a good boy, she is a good girl, that one, right? Now here I have shown you, and I have explained what are the list of stop words. Seen the theoretical part, but we have not completed the coding part of the count vectorizer. Now here we are having the good boy, good girl, and boy, girl, good. Now what I have told you, first it is going to identify the unique values. What are the unique words? Boy, girl, and good. It is going to take alphabetical order. And in the first one, boy, good is 1 time, boy is 1 time, girl is 0. In the second one, good 1 time, girl 1 time, boy 0. In the third one, 1, 1, 1. Now the same answer, this one we have seen in the theoretical part in the last class. Now let us see the coding part of this one. From sklearn.futureextraction.text, import the count vectorizer. Okay. Yes. Just Satish, we'll see that one. Just give me 2 minutes of time. Okay. So we are going to import the count vectorizer, and whatever the count vectorizer, I'm going to fit and transform on the corpus. What is meant by corpus? Corpus is nothing but this one. That is good boy, good girl, and boy, girl, good. I'm going to apply this one. And I have got the output as 1, 0, 1, 0, 1, 1, 1, 1, 1. Can you see? Now, here, sir, it is showing as an array, but where is the with respect to column names? Where is the column names? Means if you want to see the column names, you have to use a CV. CV means count vectorizer. Get the future names out. Now you are going to get the future names. What are the future names are there? What is the future names? Boy, girl, and good. Can you see the order? And if you want to combine this one and this one, so pd.data frame. You know what is meant by pd.data frame. And within the pd.data frame, I'm going to give the array as the input, and columns is equal to this list as the input. Data is this one, and column names are this one. And I'm going to create this one. So now same thing as it is. Is that okay now? Whatever we have done theoretical part and practical, both are same as it is. Now, for example, let us try, sir, can you go back and here you can keep the good boy. He is a good boy. Something you are having like this. And you have done the sentence tokenization like this. Now, whatever the sentences are there, for these sentences, now you are going to apply the text cleaning. Now you got the output as good boy. Now, any new word is added, means any new column? No, because same word, same thing. Now for this first column, this sentence will be converted as how? How many boys are there? 1. How many girls are there? 0. How many good are there? 2. So 2 words of good are there. So now what is the output you are going to get? 102. Is that clear? Why you got with 102? Because 2 goods are there. For example, sir, if I'm having third one, let us take good, boy. And girl also, girl. Something I'm writing like this. Let us create like this. After cleaning, whatever you are going to get the output, that is important, not the original. In the original, dots will be there, apostrophe s will be there. So many things will be there. So those should not be considered. Okay. If you are having that one also, and if you do this one, what happens? For one dot also, it will check how many dots are there, because it will consider one of the dot, and it will check whether the dot is also important. Right? Now tell me, in the first sentence, what I'm having? Good boy. Second sentence. Okay, let me check this one. After doing this one, we have to do this one also. Now I'm having this one. Now apply. Okay. Now good, boy. Good, boy. Now good, girl, boy, girl, good. Now, something you are having like this. First, identify what are the unique values. Tell me what are the unique values. Whether it is 3 sentences or 4 sentences or 10 sentences or 100 sentences or 10,000 sentences also, you are going to identify the unique words. What are the unique words? Unique words are good is the unique word, boy is the unique word, girl is the unique word. Make them in the sequential order. So first boy, followed by girl, followed by good. This is the sequential order. Now in this sequential order, how many goods are there? 2 are there. How many boys are there? 2 are there. How many girls are there? 0. How many good are there here? 1. How many girls are there? 2. How many boys? 0. Boy, 1, 1, 1. This is the output. If this is the data, this is the output of this one. Is that clear? Just it is counting. Count vectorization means count the word how many times repeated in that given sentence. Is that clear? No. Of course, here I have done the split now. Word tokenization only now. In the test cleaning itself, first I have removed the punctuation. After that, I have converted to lowercase and I have applied the split function. Split function is nothing but word tokenization only, right? Yes. See, first sentence I'm considering like this. After considering the sentence, I'm splitting the data now. In each sentence, I'm separating the word. Later, I'm joining again. Because I have to get finally the original sentence. Right? Now, in the same way, in the today's class, just observe this one. The original data is this one. This is the original data. And now after doing the cleaning, let us see the corpus. I have completed the cleaning. Now this is the data. Now original data is this one, where in this I'm having the first letter as caps lock, some of the commas, dot, dot, something I'm having. So now everything was cleaned. Everything was cleaned. Now everything after cleaning, now here, how many unique words are there? It is going to identify. Total 5,572 messages are there. Within the 5,572, how many unique words are there? It is going to count. Okay. And it is going to apply the count vectorizer. I'm going to apply the count vectorizer. Now, if I see my counter, total 6,296 unique words are there. 6,296 unique words columns are created. Now, for each word, one column. For each word like this, one column with 6,296. Got the point? 6,296 words it has created. Now, for the first sentence, in this sentence, which word is there? There it is going to take with respect to count. If that word is not available, 0. If the word is repeated, means how many times it is repeated, it is calculating. Now, for example, friend word is there. Friend is assume. In the first sentence, in the first mail, friend word is there, 1. In the second sentence, friend word is there, 1. In the third sentence, 2 times the friend word was repeated. In the fourth sentence, 3 times the friend word was repeated. Next 0. In the next mail, friend word is not there. In the next one, 2 is there. Assume there are total 10 mails are there. Or with respect to 6 mails are there. Overall 6 mails are there. Assume total 6 mails are there. Out of 6 mails, first mail is having friend word as 1 time. Second mail is having friend word as 1 time. Third mail is having friend word as 2 times. Friend word as 3 times. Friend word as 0. Friend word as 2. Like this I'm having. Now this friend word is there. At the same time, output also is there. So this is ham, spam, ham, spam. Now tell me how many friend is in the spam? How many times friend word is in the spam? How many times of friend word is there in the spam? How many times of friend word is in the spam? So first ham, first go with the ham. Within the ham, friend word. This is the ham, and this is the ham. So 1, 1, 3. Total 3. What is the total? 5. You are going to write 5. Spam 1 and this one. So that is 2 plus 2. So this is also ham. This is ham and this is ham. So 1 plus 1 plus 3 plus 0, which is nothing but 5. For spam, it is nothing but 4 within the spam. Same friend word. Just you are going to separate like this. How it is separated? How it is separated? In the backend, what is the code you have written? Means nothing but df of output variable. You are considering the output variable wherever it is equal to ham. First, you separate the data, ham data separated. Now within the data, now once you have separated the ham data, now you will not have this one, right? This one will not be there. This one will not be there. Now for each column, you are going to do the sum. Column wise sum. You can't do column wise sum. Huh? How to do column wise sum? df dot sum. df dot sum means for every column you will get with respect to sum now. So for friend you have separated, for every word you have separated. The same thing I have done in the this one in the PPT. Now for the whichever the ham data is there, within that friend, how many times total number of counted? So rich word, money word, beach word, office word. That's it. Assume that 5 words are there and these 5 words are repeated like this. Got the point? Is that clear? So now here we are having with respect to 5,572 maize with 4,296 unique words. And the output variable, I'm going to just take with respect to output variable, wherever the ham is there 0, spam I'm replacing with 1. Now train test split, you are going to apply the train test split. And after applying the train test split, now you are going to do the modeling. That is sklearn.navbase, import the Navbase theorem, that is multinomial theorem. And okay, first you are going to import. First line, second line is save, third line is fit on xtrain ytrain. Now when you apply on xtrain ytrain, what it is going to do? Just it is going to calculate prior probability. It is going to calculate in the backend of xtrain ytrain is it is going to calculate the prior probability, and along with the each word, what is the probability? Just it is going to calculate these two things. In the backend, it is just calculating these two. Is that clear? Online students, as one of the student is saying that voice is not clear and it is breaking. Can you confirm? Can you confirm, guys? It is clear only, right? So when you are doing the prior probability, just it is when you fit on xtrain ytrain, it is calculating the prior probability separately, and it is calculating for each word what is the probability being in ham, what is the probability being in spam. In the backend, it is calculating this one and this one, likelihood and prior probabilities. Got the point? Once it is calculated, fit on xtrain ytrain is completed. Sir, xtrain ytrain. Ytrain means in the train data, how many spams are there, how many hams are there. First, it will separate, and within the ham, it will identify each unique word and their sum. In the ham, each unique word and their sum. For example, sir, if you want still more crystal clarity, take 10 sentences of your choice. Any 10 sentences. Write in the notes any 10 sentences. Whatever the sentences you want, you write as per your choice. And for each word, you add ham, spam, ham, something like this. You only add, you only create your own data. 10 messages. Along with the 10 messages, you give the ham and spam words. Okay. Something like this you have created. Now, out of 10, first you separate the data, which is train data separately, you separate, test data you separate. Means 8 records you separate for your training purpose, 2 records you separate for your testing purpose. Randomly you choose which are the data you want. Absolutely no problem. Now 8 records you are having with you, right? 8 records are with you. Now within these 8 records, whatever the 8 records are with you, now within these 8 records, now you take with respect to first one, how many separate the ham records, separate the spam records. Within the 8, some spam will be there, some ham also will be there. Separate them. How many spam are there, how many ham are there, separate them. Now, within the ham, whatever you have separated, within the train data, don't forget about the test data. You don't focus on the test data. Forget, it is not there. Just focus only on the train data. On the train data, you are having 8 records. In the 8 records, first identify how many ham are there, how many spam are there. Now, within this, calculate the prior probability. With that, prior probability will be completed. After that, these 8 records, do the cleaning and apply the stemming. Do the cleaning, that is remove the punctuations and remove the stop words, whatever is there, and do the with respect to stemming. Completed. Stemming also completed. Everything is ready. Now, you are going to take the each word, bag of words. So total, how many sentences you are going to get? How many records you are going to get? 8 records. Rows are 8. How many columns you are going to get? That is going to depend on the number of words, number of unique words. Assume that in your data, total 10 unique words are there. 8 columns, 8 rows into 10 columns. Columns are words, 10 unique words are there. And along with in the output also, you are having with respect to spam and ham. Okay, in the train data, you are having spam and ham. Now, out of these 8 records, first you separate the spam records. First you separate the spam records. Separate the ham records. Separate. You know how to separate, right? Just by applying the filtering condition, and you are going to separate the data. Now, within the spam, identify what are the unique words and their count. Identify unique word and their count, total number of. Write that one separately. In the ham, for each word, what is the count? Word and the count. Word with respect to count. Create a table like this. A word with count. What are the words are there in the spam maze and what is the count of that one? What are the words are there in the spam maze and count that one. Okay. Some words might be available here. Some words, new words might be available in the spam also. Don't worry. Just you separate first. Okay. After separating, once it is completed, the separation is completed. Calculate the probability for each word. You know how to calculate. That is nothing but for this one divide by total. For everything divide by total you have to do, and you have to calculate the probability. Similarly, you calculate the probability of this one. Completed. With this, training is completed. Fit on X train, Y train means this is the meaning. Calculating the prior probability, calculating for each word what is the probability in ham, calculating for each word what is the probability in the spam. With this, training is completed. Now, what we are going to do, predict on the model dot predict on X test. You are predicting on the X test. Means now new data, whatever the new data is there, that new data you are going to predict. So while predicting, first mail in that every word will be the right. First it will take the first one. Okay, first sentence. Whatever the first sentence is there, first sentence, it will take the first sentence in that whatever the words are there. For each word, it will calculate what is the probability associated with the already calculation is completed. Just it will substitute now and it will calculate the total value. And it will calculate for the first sentence, what is the probability of being as a spam. And for the first sentence, what is the probability of being as a ham. And whichever the probability is high, it is going to select into that one. And it will predict the output as ham or spam accordingly. Original answer also is there, right? What is the original answer? Y test is the original answer. This is the predicted model predicted on X test. This is the predicted values. This is Y hat test. And you are having the Y hat test answers. That is nothing but in your case, earlier you have taken 10, right? Out of 10, 8 are used for training. Now remaining 2 are there. Now using that 2, you calculate whether it is answer is what is the probability. Original answer, forget. Don't see the original answer. Without seeing the original answer, you do the calculation manually. After doing the calculation manually, now whatever the answers of 2 answers you have predicted using the model by applying the calculation, whatever the answers, now you see the original answers and check what is the accuracy. The same thing will be done here. Model.predict on X test, and I'm going to check the accuracy. What is the accuracy? Miss? It is giving 97% accuracy. Simple. Now the question would be, sir, if some words are available in the spam, the words are not available in the ham. For example, friend, lottery, something, these two words are there. Assume you got a new mail. This is the new mail. A new mail, after cleaning, this is the answer. After cleaning, you have left out only two words. Now, how to calculate the probability that this new mail being as a spam? How to calculate? First, you are going to take the prior probability, that is probability of ham separately, into probability of friend being as a ham. What is the probability of lottery being as a ham? Similarly, probability of spam separately into probability of friend with spam into probability of lottery with spam. Done. Now, sir, friend with spam is available, friend lottery with spam is available, but in my entire ham data, there is no word of lottery. Now what I have to do? Since there is no word of lottery, if I substitute 0, 0 into everything will be 0 only now. So now what I have to do? This is the question. That is the interview question. Interview question is with respect to zero frequency. If there is a zero frequency, frequency means count. If there is a zero counts of that particular word, then what you are going to do? That is the one of the most important interview question. For this, two options are there. For this, we can apply two logics. Logic number one, whichever the word is not available, that word can be ignored. For ignored, that word can be ignored. If remaining words you have to consider. Whichever the word is not available, that word should be ignored. Now, if it is ignored, okay, sir, if it is ignored, every time it will be ignored, na? For the future mails also it will be ignored. No, it is not considered like that. For example, for this new mail, you are classifying this one. For new mail, you are classifying. For example, let us open like this. My mail, I'm opening my mail. Okay. What are I'm having the mail, that is srk.datascience. So this is the mail. So I'm opening the mail. Here I'm having with respect to some mail. Now in this mail, okay, here I'm having with respect to different mails, and within these mails, if I open this first mail, if I click on this mail, okay, now here I have received one mail related to data science bootcamp from the Wodin school, where I'm the trainer. Okay, here also I'm the trainer. I'll be taking the classes at the weekends. Okay, forget. Let us assume this. I'm going to click on the report spam. Don't focus on what is there inside. Just focus on what I'm saying. Okay, report spam. If I click on the report spam, what happens means in the future, these words also will be associated in the spam. Whatever earlier I'm having, along with that, these words also will be added in the spam mails. This count also will be added. This is also going to count. Okay, got the point? So here I'm having with respect to just, for example, IDFC Bank, I have received something. I have reported to spam. I have clicked on the report to spam. Automatically, it is going to add with respect to the words, whatever the individual words are there, every individual word count will be added in the spam. Means this record also will be added to the original data. Earlier, my original data was with respect to 100 records. Means now my original data will be converted as 101 record. So the training data will be increased. The more the training data is there, the more accuracy you'll get. More amount of data is there means more clarity will get, right? Instead of working on a single record and instead of working on 100 records, analysis will be different. So the Gmail will work in this way. Sir, now for example, assume that in my entire, I have created a Gmail account now only. Just now I have created. 5 minutes back I have created. And one of my friend has sent a mail. And how the Gmail is going to classify whether it is as a normal mail or whether it is a spam mail, how the Gmail knows that one? By default, if you have created that one, unless you create unless you generate the data, it will take by existing data. Whatever the Google is having the data with Google, For each word, the Google is having separately the spam mail, ham mail. That will be used by default. By default, it will use that one. So for example, you have got Naresh IT. Whatever the Naresh from Naresh IT, whatever the mails you are getting, you are reporting on the spam. You have selected spam. For example, I have selected the IDFC Bank. Whatever the IDFC Bank message I have got here, this message, okay, I'm going to click on the report to spam. Next time onwards, whatever the related messages of IDFC is there, that will be stored in spam for me. So for me, it is storing means for yours it will store. No, because this is my data. Because I have reported to spam. I have reported to spam, so it is considered for me only. If I don't report to spam, by default, it is going to take with respect to whatever the Google is having, that will be considered. When you have reported to spam, separately your data will be separated. When whatever the data you are clicked on the subscribe, for example, some websites you'll watch, in that you'll give your mail IDs, and from that you'll get the mails, some mails. So some mails you are going to get, complete new mails you are going to get from different web sources, you'll get a mails. By default, it is going to classify that one till you click on the unsubscribe or till you click on the report to spam, it will not do any modifications. So, sir, why some of the students has received earlier in the starting, first day of the Naresh IT, when I have sent the Google Class invite, some people have got that invite in the classroom, I mean, inbox. Some people has received that Google Classroom invite in the spam. Why they have received like that? Why some students has received it inbox and some students has received spam? That depends on your mail earlier, how many things you have observed and how many things you have clicked on the unsubscribe. So for example, if here there is an option for me to click on the unsubscribe, where is that? If I want to unsubscribe, if I click on this unsubscribe, so and here if I select this reason, what are the reason, if it is asking the reason, it is not related to me, means all the banking related will not be shared to me. Everything will automatically goes to the promotions or with respect to spam. Okay. If I click on unsubscribe, means automatically instead of getting in the inbox, now we can see this I have got in the inbox. My inbox mails of 2 and 2 of them are IDFC only. Okay. For example, if I click on the unsubscribe, then automatically I'll never get any mail also. Or if I click on the spam, means new mails will be sent automatically to my spam. Is that clear? In this way, it is going to work. So option number 1, if any new word is not available in your data, original data, option number 1 is ignore the data. Option number 2, second option we are having. What is the second option? For example, if this word is not available in your spam, that word is not available in the spam, if you take as 0, the overall answer is going to be 0, which is called as wrong answer. Now for this, what you have to do is you have to add every data point with 1, and along with this word also, first time this word is getting repeat, first time you are seeing that word now, for that 1 by, and for every word you have to add 1 1 1 1. This word also you have to include as a new word. Since this word also included, total number of words also increase, right? Automatically everything will be increased. So accordingly, you are going to calculate the new count. Okay, this is one way. That is one way. Ignoring is one way. Second one is for every word you are going to add +1. Okay, is that clear, guys? So in this way, we are going to work on the spam data. Now, sir, okay, you have created the model, everything was done. Whether it is a good model or a bad model, means again, you are going to check with respect to train accuracy and cross-validation score. Common, no difference. So whatever we have done earlier, the same thing. Train accuracy, test accuracy. Train should be equal to test. Then only it is called as a good model. Otherwise, it is called as overfitted or underfitted. At the same time, test accuracy should be equal to cross-validation score. Now, if you want to predict on a new data, for example, a new mail is there. Okay, I have trained the model, completed a new mail. This new mail, what happens? First, it is going to be converted like this. And this mail, first I'm going to do the cleaning and I'm going to do the vectorization. Now it will be converted as a structured data. After converting as a structured data, now whatever the structured data is there, that is X. Now this is the array. It is converted as a structured data. What is the shape of this one? Can anyone tell me what is the shape? With respect to 2D, two-dimensional, one row, how many columns? Columns are 6,296. Columns will be fixed. If that number is available means is 1. If it is not available means 0. Columns are already fixed with 6,296. It is not going to change. If I ask my shape, it is one row with 6,296. Right? Now, this data, whatever the X data is there, this data, I'm going to ask model.predict on X. And if the output is 0, either it will give the output as 0 or 1. What is the meaning of 0? 0 means ham. Why ham? Because I have done the replacement ham with 0 and spam with 1. So I have considered like that. So since predicted answer is 0 means it is considered as ham. Predicted answer is this one means spam. So it is predicting the output as 1. Since output as 1, it is going to give the output as spam. Is that clear? Means anyone is sending, you have won a lottery of 1 crore means it is a spam mail based on the past data. For example, hi. Hello, sir. How are you? How are you? Some person has sent me a mail like this. Now, in this, first it is going to do the cleaning. After cleaning, again, it is going to check how many hellos are there. Count. How many with respect to sirs. Like this, it is going to count. Now, what is the probability? So now it is going to do the cleaning. Cleaning means punctuation marks will be removed. Okay, question mark, comma, both will be removed. After that, stop words. Stop words means R word, U word will be removed. Now what is left out? How also will remove. Only hello and sir. Only these two words will be left out. After removing the stop words, only these two will be left out. Now what it is going to do? Probability of prior probability of ham into probability of hello with ham and probability of sir with ham. And similarly, what is the probability of spam? And what is the probability of hello with spam? And what is the probability of sir with spam? It is going to do like this. After calculating these both of them, whichever is having the higher probability, it is going to select that one. Model.predict on miss, predict miss, it is going to work in this one. In this way, it is going to work. After doing this one, it is going to tell me which is nothing but ham. It is a normal mail. Why it is considered normal mail miss? Because more number of words of hello is hello or sir words are associated with ham instead of being as a spam. In the spam mails, hello sir is less. Sir, assume that hello sir is not there, sir. In my entire data, hello is not there, sir is not there. How it has worked then? Means ignored. It has ignored this one. If this both the words are not there in the ham, if both the words are not there in the spam, by default, which is having the more probability? Ham is having more probability. That is the reason it is showing us ham as the output. In my data set, hello is not there, sir is not there. But still it is giving the ham as the output because it is just ignoring the whichever the words are not there, it is just ignoring. Is that clear, guys? So in this way, the sentiment analysis will be working. That is whether it is a, for example, sentiment analysis output is whether it is a positive or negative, good trainer or a bad trainer, something. So whatever your feedbacks, students are going to give the feedbacks. Now, for every feedback, initial data, first time when we are collecting the feedback from the initial data, at that time, we have to give the labeling. We have to write the label for that. Because first data itself, none of them knows whether it is a good or bad. First, initially, first 100 mails or 200 comments, we have to do the labeling. Using that one, in the future data, we can predict directly. Without seeing that one also, without reading the sentence also, we can directly predict. Within 5 minutes, everything will be completed. Now, in Naresh IT, if I open my Naresh IT Google reviews, If I open the Naresh IT Google reviews, in the Google reviews, I'm having overall Google reviews of 5,600 reviews are there approximately. In that, we are having with respect to some of the Google good reviews are there, bad reviews are there. For example, some new student has added a review. I no need to open that one. I no need to check that one, but still I can get the answer as whether it is a positive or negative. I can predict directly without seeing that one also. Because internally the project was created like that. Simple. Is that clear, guys? So that is with respect to called as sentimental analysis. And in tomorrow's class, we are going to do one more project related to NLP, that is document clustering. And if anyone having the doubt, yesterday's class and today's class, again, if you want, miss, go to the YouTube. In the YouTube, just type data science project. In the YouTube, just click on the YouTube. If possible, can you open now? In the just open now and click on the search button, data science project using Python by Sivaramakrishna. Just type in the Google. Data science project using Python by Sivaramakrishna. In the YouTube, just type like this. Automatically, you'll get one project. That project is whatever we have discussed yesterday and today. There I have explained in half an hour. Here I have explained 3 hours. If you feel this one only fast means that is ultra fast. Then you have to keep at 0.1x and you have to listen that one. Right? You can open and you can go through this once again. Got the point, guys? So I'm going to upload the notes and please practice. Yeah, just a minute. I'm going to take your questions. Satish, yes, I'm going to upload yesterday's class and today's class. And Satish, you are saying that there is a problem in the download now. Can you please share me your screen tomorrow? Without screen sharing, we can't explain anything. Just you have to share the screen between 2 to 4. Tomorrow between 2 to 4, just share your screen. Okay. Done. Yes, I have uploaded the notes also, guys, and you can practice. Yesterday's class, today's class, and even tomorrow's class also I have uploaded. Done. Even tomorrow's class also already uploaded. You can go through that. Don't open the tomorrow's class, just open the today's class. If you open tomorrow's also, you'll not understand anything. Okay. So we are having different types of vectorizer. In that, count vectorizer was completed. And with respect to count vectorizer and sentiment analysis project is completed. So tomorrow we are going to see one more type of vectorizer that is called as TF-IDF vectorizer. And in which cases we are going to use that one that we'll see in the tomorrow's class. And along with that, recommendation engines also we are going to see in the tomorrow's class. Recommendation engines also works in the same way. And where I'm going to select the movie data set, IMDb movies data set, where you'll have with in the Netflix, it is going to recommend us some movies now in the Netflix or in the Amazon Prime. It is recommending some movies. How it is working, that we are going to see in the tomorrow's class. The recommendation engines theoretical part and practical part. Completely, it is also based on the text only. Okay, done.